It's like the escape pod. It's the perfect place. So we'll see, unless it starts raining really hard, and then I might have to go inside. So we might take a 2-minute break somewhere along the way. We'll see how it goes. And did I hear somebody say A? Because there's a Canadian in the room, I heard. All right, we'll get started. Let's see, how do I do this?
No, there's no hey. To say hey, you have to come from Manitoba, Saskatchewan, not from
Quebec. All right. Let's see. Do you all see a little screen there that talks radical simplicity? Is that up there?
Yes, it
Hello?
looks like.
Yes,
Yes.
Mike, we're all set over here.
We're on. Okay, great. Thanks for the invitation, Courtney and everybody at CSI to talk about this subject. It's dear to my heart. I'm an architect by vocation and passion and training, and 21 years ago now, I took a right turn and entered the construction side of the industry with Walsh Construction originally to build the quality program in the company, and did that for nearly 10 years, and then took over as the general manager of the Oregon operation for Walsh for another 10 years or so. And then a couple of years ago, I stepped out of that and into a new position that we've called Director of Innovation, which is really code for stepping in and taking on special projects where we have clients that are interested in new technologies or new delivery methods, something that's been near and dear to my heart all the time that I've been practicing. And it's been fruitful for the last 2-3 years while we've been doing this, where we've explored a bunch of new areas, which I'll talk about to some degree here today. I talk about exploring a path towards more cost-efficient, more energy-efficient, affordable housing, and approaching it with radical simplicity, which, as you'll hear a little later, I have to acknowledge credit for the term to somebody else, but it came up along the way. We have a very boring term that we use called CEDC, which you'll hear about again in a few minutes. Let's see. There we go. So we're going to, I'm going to talk about a path that we've been exploring, and it's not the path. I believe there's many ways to get to the same destination or achieve the same goal, but we've at Walsh have been exploring a particular path, actually many paths, but one that we've really been dialing deep into, and that's what I'm going to talk about today. But first, I'll talk in a framing manner about the key issues that we're facing, which has to do with the affordability of our housing, and cost certainly being a key part of that. And then lingering, not frankly too far in the background, is the issue of climate change and some of the environmental disruptions that we face as a society. And it certainly interfaces with what we do when we design, build, and deliver housing and operate it. So I'll talk a little bit about that at the beginning here, and then spend most of the time talking about how we might address these issues, a little bit about energy efficiency, and I would sort of suggest that I believe the industry has talked ad nauseum about energy efficiency, and for good reasons. But the problem is we've sort of ignored this other issue, which is cost efficiency. So I'm going to talk a little bit about energy efficiency as a way of addressing the issue of the climate change and affordability as well. But I'm going to talk mostly about this notion of cost efficiency and elevating that in our thought process. And then we'll save 15 minutes or so at the end for a presentation of a couple of case study demonstration projects of some of the ideas we've been working up. help frame the issue, I want to talk about our Orchards at Orenco project that we worked on, completed a year and a half ago now, but worked on for many years over the last 8 to 10 years. And this is a three-phase, large-scale mostly workforce affordable housing project out in Hillsborough in the Orenco Station neighborhood. We started that project in 2012, working with Reach Community Development, and took 6 years to get all three phases done, designed and then completed. And along the way, we covered some really great ground and accomplished some great things. This is a view of the site plan of the project. Far to the left, you can just barely see it off the screen. There's the Orenco Station light rail stop. So this is literally right across the street from that great transit-oriented development site. And Reach came upon this property that they decided to basically cut up into 3 pieces to execute in 3 phases, mainly due to the sort of bite-sized nature of affordable housing development. When you're using tax credits, you can only do so many units in a given project typically. So we worked with them to program this project, and Anchor Moyson was a great design partner on the project with the team. William Wilson Architects was involved early in the project as well. But it was a fantastic team working towards Reach's goals. And one of their goals was certainly to deliver the affordable housing, but even more important, in their view, they wanted to do a large-scale project. It was written into their 5-year plan in 2010, and by 2015, they wanted to deliver a passive house certified project of large scale in the affordable housing community. Dee Walsh, who was the executive director, had toured in Europe and had been fascinated by what she had seen there with several other nonprofit developers from the US, and came back lit up by that vision. And they put it in a plan at Reach. And again, we started in 2012, and by summer 2015, we had delivered the first project for operation. And that was 57 units of affordable workforce housing. The building was about 58,000 square feet. We achieved FIAS Plus certification, in this case under the German PHI passive house standard, and measured EUI, the building, for those who are kind of geeky on EUI, is 21, which actually is a couple points below what the measure or the predicted EUI was. So great results at that building. And if you're measuring cost, the cost per unit for the project was just under $160,000 a unit, and $158 on per square foot on that basis, which, as you'll hear me allude to a little bit in this talk, is not the best measure of cost measurement between projects, but it is one that people use. So, and also of note is that when we did the math and looked at the things that we did on phase 1 of Orchards that people typically, or that Reach typically didn't do on their projects, they go beyond code minimum typically with their specs and standards, but to the extent we went above and beyond that, we deemed this project to have an 11% cost premium to achieve passive house. So it was significant, but it was still a major accomplishment for both Reach and all the project partners, and frankly for the affordable housing industry at the time. Fast forward 1 year to the start of 2015, as we finished phase 1, we began construction of phase 2, and this project is roughly the same size, 58 units. The building is significantly smaller, and I'll get into that in more detail a little bit later. So it's just under 50,000 square feet, whereas the phase 1 building was 58,000. Finished it a year later, and this project also is FIAS certified passive house building. It pursued the new North American building standard, passive building standard that had been issued in the interim between phase 1 and phase 2. And the measured EUI at that building is 22. Construction costs notably went down between phase 1 and phase 2, down to 147,000 a unit. Roughly the same unit mix, mostly 1 bedroom, some 2 bedrooms. The cost per square foot actually went up, and you'll see how that happened here in a little bit. But overall, between the 2 phases, it was a 8% cost reduction, and when you factor in the escalation in the market that was happening there, it was actually over a 50% cost reduction to deliver phase 2 from phase 1. And notably, we reduced the premium to achieve passive house to just 5%, which had a lot to do with just kind of optimization of our design and you know, the things we learned on phase 1, we were able to kind of fine tune for phase 2. Phase 3 is a little bit different in that the first 2 phases were workforce housing, and the 3rd phase was family housing. You'll note each phase, again, all of them were designed by Anchor Moisen. They all had a little bit different look and expression and form, but there's many elements that tie the projects together as well. This project is a little smaller in unit count, 52, but they're larger units. Quite a few 2 bedrooms, a few 3 bedrooms, and only a few 1s. And 62,000 square foot building. Again, a little bit larger building because of the larger units. And we finished this, actually there was a year gap between phase 2 and when we finished phase 2 and when we started phase 3, and that had to do with the funding cycles at the state, the tax credit allocations, and phase 3 wasn't successful in its first application, so it sat in the drawer for a year. And while it was sitting in the drawer, all of our goals and Reach's goals were still intact, which included pursuing passive house on phase 3. And we certainly studied it with the design team extensively, but when the project did start moving forward, it was decided not to pursue it. The measures were going to cost too much in the market at that time to be able to finance the project. So we did not pursue passive house certification in phase 3. It's still it's a Earth Advantage Gold building. It's well above code minimum, but not passive house. So, and then the metrics on the cost standpoint were 198,000 a unit. So that went up considerably. Of course, these are larger units, more family size units. Cost per square foot went to 164, down actually from the other phase. But again, this is we call it pound cake versus angel cake. Family housing is more like angel cake. There's fewer bathrooms and kitchens and doors and such. So the cost per square foot actually goes down with larger units. But notably, the project suffered a lot of cost escalation in those 2 years between when we started phase 2 and phase 3. So it was sad times for us because we'd accomplished a lot with the first 2 phases of the project, and we weren't able to achieve that sort of gold standard result on phase 3. And again, we're all passionate about this. The folks at Reach are, folks at Ankrum, folks at Walsh, our team. We wanted to do it, and it really aided us. It aided me that we didn't get it done on phase 3, and so that's just kind of a parable, I think, about what we face in the industry right now when we're thinking about providing more housing that's needed. We've got an affordable housing crisis. I like to say we need more housing, and it needs to be better housing. It needs to be really well built, well designed, well built. It needs to be durable, and it needs to be, super efficient, energy efficient to deal with these, environmental impacts that we're experiencing and that we need to mitigate much better than we are currently. But while we're facing those challenges and trying to meet those goals, we face this challenge, which is construction cost escalation. And this is just a chart put put together by a fellow named Ed Zarinsky. And basically he's tracking construction costs over the last 15 years, and you see a big steady rise in costs. And this is tracking actually the cost indices put together by different reporting systems in the industry, some companies, and then such places as RS Means and such. And you'll note the tilt downward during the Great Recession in 2008 and afterwards, and then a steady ramp back up in the early 2010, 11, 12 range. And then what happened is in 2014 or 15, 14, I think, is when it really hit. We really started experiencing a lot of escalation, and that's a whole nother discussion topic and the reasons for that. But safe to say that in the Northwest, Pacific Northwest, in the multi-residential construction market, which is a unique niche in the market, serviced by what I will call a lot of undercapitalized and, let's just say, less sophisticated subcontractors. The market was overwhelmed and with work, with basically activity, and costs started escalating. And we believe between 2014 and 2016 or 17, we were seeing double-digit escalation in the Northwest, in the multifamily market, specifically in the centers like Portland and Seattle. Normally the inflation rate of escalation rate for construction is in the 3 to 4% range, and what this chart is showing is that it's more in the 6 to 7% range there during that period from 2014 to to the present, really. But it was it was significantly higher than that in our region and in the multifamily market. So a huge challenge for us while we're trying to achieve these goals. And so we've gotten our heads around this issue of construction costs, and there's a lot of costs that go into putting affordable housing together. Why so much focus on construction costs? Well, this chart shows why, because it's by far the biggest piece of the pie. It's where we can move the meter the most if we can figure out ways to reduce cost. So that's what we're focused on for this talk, but there's a whole slew of other issues that relate to the cost of affordable housing that are in those other line items down below, and they need to be addressed in some ways as well. When we think of what is construction cost, it's essentially the divisions of the work all added up. So that's, that's some big ones like in affordable housing. The wood structure tends to be a very large piece. Finishes are a large piece, the mechanical, electrical. We have a general category at the start there for site supervision and such. We have what we call the other category that might cover the safety plans for the project, the hoisting and access for the work, miscellaneous other items. And then at the end, a little bit of something for the trouble of the general contractor, overhead and profit, and insurance, a small amount typically. And when we add all of that up, that is what is essentially construction cost, or what we also refer to as the hard cost of the project. So we sort of step back and say, what if, to address this housing affordability issue, to address the numbers issue, how are we going to deliver more housing, especially with a limited amount of resources to do it? How could we work as teams in the industry to push costs back, given this wave of cost we've been facing for the last almost 10 years now? And we conceived this idea of just conceptually, what could we do as teams to push costs back 20%? I know we would have to do a lot to do that, but let's start thinking about that and talking about that, how we can do that as teams. And if we could do that, what could we do with those savings that we could make. And in the niche that we work in affordable housing, where a lot of Walsh's work is, we work with mission-driven clients and owners they're not about building and flipping properties. They build and hold for the long term. They have other missions to what they do with their buildings, take care of people, support the community. And part of that is a better living environment and a more efficient environment that costs less to operate, not just for themselves, but for the people who live in the homes that they create. So our clients are very interested in performance and always have been for the last 20, 25 years that the green building movement has moved forward. They've been very proactive and emphatic about embracing that. So we know that's important to our clients. We also know that maybe you don't unmute, but raise your hand if there's any architects in the room. I believe there probably are some. I'm an architect. Yay! I'm an architect as well, and so what I want to stress that we want to account for differentiation and amenities and such, and I just use the term joy for that. You can lump beauty in there, whatever you would like, but we're not talking about creating barracks and minimum existence dwellings and really crummy buildings. We're talking about really great buildings, what I call better buildings. And so the idea there is if we can find ways to work diligently to reduce cost that much, and then we can create room to have these performance features and amenities in our buildings and still reduce cost. And our idea is shoot for 10% cost reduction, but really better buildings coming out of that from what we're seeing today. And I'm sure many of you are there where we have been, where we've just seen a lot of projects get reduced in quality, just desperately sort of hacked at during value engineering processes late in the game because of runaway cost escalation. And we're trying to create a more emphatic way to address that and turn that on its head and be able to build quality back into the projects through our process. So how might we do that? We look at it a couple different ways. One is by applying a set of principles of cost-efficient design to the overall design of the buildings, and in many cases to the subsystems that go into the building, focusing on using more standardization, more repetition, more prefabrication to the extent it's valuable in projects, and also looking to use the economy of scale whenever possible. So that is really typically site dependent, but again, it comes into play when you can find larger sites as a developer and as designing construction teams. You've got more potential to reduce costs and be more cost efficient. I'll talk about those in more detail in a minute. The other thing is just the idea of opening up the lean construction toolkit and not doing everything in there, not taking all of the tools out and using them all at once, but selectively using some of those tools to make a better process. So things we've been experimenting with is, well, the first one really applies to the design process and what is called optimizing the widget. And in the case of housing, it's your unit plan. For a hospital, it would be your patient rooms or your operating rooms. For a school, it's your classroom. For affordable housing, it's the unit plan. So optimize that as your basic building block for creating more efficient buildings. And we'll get into that in a little detail. I won't have a lot of time for that. So more integration. So I think we're, as an industry, especially in the Northwest, we tend to work fairly integrated with owners, designers, and contractors, but taking it deeper than that, and especially including subcontractors. And what I mean by that, including the subs, MEP subs is very typical or normal to bring into projects in many cases, but we're talking about bringing the structural sub, sometimes the cladding sub in, the drywall sub, all those categories of work, the top, what I call the top 10 categories of work where most of the money is spent, bring those subs in and get them involved in the conversation. And in many cases, negotiate the work with them, especially in a difficult, competitive environment, or let's call it a non-competitive environment where the subs are sort of in control because there's so few of them and so much work. It's better to engage them and bring them in early when you have a procurement system that will allow you to do that. Another idea is target value design, and this is another topic for a talk, but the basic idea there is that you estimate the design or you estimate the program of the project before you begin design. And in our case, on the 124th Nash project I'll talk about, we literally laid out the estimate of the project before the design process started, and the design was essentially validated in the sense that it tracked to the target value design and estimate that was created early in the process, which was intended to achieve the owner's target cost goal for the project. And then just the last idea is eliminating waste wherever you find it in the project stream, during design, during construction, always looking for ways to reduce and possibly eliminate waste. So with cost-efficient design and construction, basically Walsh has been building affordable housing in the Pacific Northwest for over 50 years. And we basically said this cost issue is so critical now to the clients, we're just going to lay out all of our ideas as clearly as we can, as simply as we can. And we kind of created a white paper with these ideas. And anybody listening who's interested in that, I can provide it to you if you reach out to me at the end of the talk or after the talk. The last slide in the talk has my email address, and we welcome people reaching out for this information. I'm not going to get into the specifics of it, of the principles here because we're time limited, but it's what I essentially, I call it, I grew up in the Midwest, and I call it farmer's common sense. It's all pretty straightforward stuff. It's stuff that you basically know. Almost I feel like I need to apologize for writing it down for the industry and for certain members of development, design, and construction community, because many of these principles aren't followed on many affordable housing projects and their designs. So none of this will actually be earth-shaking to any of you, but it was the exercise of putting it together was more about just taking stock of it all and making it as clear as possible as we could. These first three items are really issues of project conception, and they really they are less in the design sphere and the construction sphere than they are in the developer sphere in terms of site selection and just how they assemble teams and conceive of their project and lead their projects. And we'll talk about unencumbered sites. What I mean by unencumbered sites is sites that they aren't highly sloped. They don't have a lot of buried rock. They don't have a lot of buried nasty things in the ground. They have all the utilities at curbside, or at least in the center of the street, if possible. And of course, we rarely see sites like that anymore, and particularly in our bigger urban areas. But those are the kind of sites that could be helpful in terms of pursuing affordable housing. The fifth bullet down the list is really critical. So I've talked about optimizing the widget. We'll talk about that a little bit more in a minute. But just the notion of using very efficient unit plans and focusing on this idea of a narrow aspect ratio, which is the notion that whatever the size of unit you have in a building layout, think in terms of making that unit as narrow as you can, and then make it as deep as it needs to be, and that is to accommodate all the relevant functions for the home, the apartment. And it's also very important not to take it too far. You can get apartments to be too narrow, and then they're not functional or livable anymore. And a classic example of that is what's called in Seattle, they call it the urban one bedroom. We don't see them as much in Portland. They're everywhere in Seattle, and that's basically the one bedroom that has the bedroom internal, either at the corridor wall or mid position within the apartment, borrowing a little bit of light from the living area and the kitchen and dining area. But it's not a really good design practice in terms of aspect and livability, having daylight and ventilation into a bedroom. So, and in fact, in the affordable industry, that's not allowed. OHCS won't fund a project. Oregon Housing Community Services, they won't fund a project that doesn't have a bedroom or doesn't have a window in the bedroom. So continuing on, another set of principles in the CEDC canon. Again, the white paper outlines them in details. Some of these y'all can live with if you're architects out there. Some of them might be a little hard, bitter pills to swallow. But these are frankly what was done 20, 30 years ago and prior to that in historical traditional construction and in, let's just call it the cost-effective, affordable construction of the 60s, 70s, and 80s that we moved away from largely in the last 20 years or so. Another way of looking at this is if we think about multifamily buildings, we can think of them as assemblages of components and elements. And in our conception of CEDC, we think as teams, we can do a lot of work to focus on those elements that you see in the column on the left and focus towards more standardization of those. And when you have standardized, that opens the possibility for optimization. When everything is always a one-off and new, there's no opportunity for optimization, because optimization really comes from fine-tuning and making it better a little bit, but keeping most of the elements of something. But we also recognize that we're not out. We don't intend to. We're not proposing that developers and architects working with them are going to design cookie-cutter buildings, the same building for different sites all over the place. We understand that every site is unique. The program that goes with every site is typically quite unique, and that in itself will require customization, and then any manner of things that have to do with the site, its configuration, how the corner bound lines come together, what's the zoning envelope and overlay, what do the neighboring buildings look like. All of those things are factors we all know about. And so our idea is to really focus on the things that we can standardize, and that's roughly the 80% of the building, and or could be even more. And if we focus on that, we're going to drive costs down in all of those standardized repetitive elements, and that in turn will create, frankly, if you follow it with a lot of discipline, it will create a lot of room in a given budget to really focus design attention and materiality to the items on the right that can actually make the place unique and special. Any questions at this point? Is everything coming through loud and clear? Can somebody say yes?
Yes.
Yes, yes,
Okay.
Mike. I do have
Okay.
a couple of questions from the crowd today. Do you want to?
Great.
So when you were talking about the unit costs originally, when you were looking at the Orenco project, when you're referring to the cost per square foot, is that including the site, or is that building only?
That is the site included, yes. It's not just vertical construction.
Okay. And then the second question was regarding bringing in trades and subs early in the process. How do you go about doing that in a competitive bidding environment and process? Do you bid early, certain aspects of the trades, or how do you manage doing that?
Well, the first and foremost thing is you follow your procurement rules that you're dealt with by your client and by your client stakeholders and funders, whoever those are. So that's the first rule. But when you have flexibility, I mean, our instinct is always to be able to shop the market, right? That makes sense. But in the current environment, where in the multifamily world, there's only 3 or 4 framers in the Portland area that can even frame a 100+ unit project, and they're pretty dang busy. So, I mean, things are going to hopefully probably change given current dynamics, but that remains to be seen. But certainly for the last 3 or 4 years, getting bids for the framing package, as an example, is hard to do. And if you actually wait until you've got 100% construction documents and a bid set to go out, your framers, those 4 framers I'm talking about, their book of business is filled for the next 1.5 years. So they're not even going to look at your project. So you're out of luck. So you have to approach these things with a mind to the current market dynamics. So when it comes to the large trades like the framers, the drywallers, the MEP subs, you really have to think in terms of engaging them early. And typically in multifamily, even multifamily that's taking public subsidy, you still have the flexibility to engage early. And when we do that, what we try to do is have a really good scoping document that's developed by the design team and us as the GC as early in the process as makes sense, and then get that out to as many of these subs as you can. And so basically, you don't have final design documents and specs, but you got 90% of it there, right? And you're basically scoping it out that way, getting pricing, and you're doing your competitive shopping at that point in time. But it's usually, the sweet spot is usually at the end of design development. Sometimes with a more complex system, you might even do it at the end of schematic design. But so
Awesome.
hopefully that helps.
I think that helps out a lot. That scoping document, I know, has come back, and it's always a great tool. So
yeah, many times, for example, the mechanical engineering firms and the MEP firms, the design firms will do a narrative to supplement a set of plans that the architect's able to put together, and we can go out and get competitive numbers, 3 or 4 numbers from subs there, and it's not a hard bid, but it's the best you can do in the current environment, I think. Maybe that's going to change. So if it does, frankly, there's a potential that it will help us as an industry to bring some costs down, because I don't fault the subcontractors for getting their share of profits and margin while times have been good, but because they weren't getting it, between 2008 and 2011, they were hardly getting anything. So they've had it good for a while. Who knows if what we're going through right now is a small hiccup, or if it's a major structural change that's going to make the subs hungry again. So we'll just have to see.
that's it from our group for now. If you'd like to
Okay.
continue.
So there's a whole lot to talk about when it comes to the unit plans. I talked about the widget for affordable housing is the unit plan, and I just want to take a quick walk through unit plans at our Orchards project as a demonstration of some of these, some of this optimizing that can happen. When we started phase 2 on Orchards, we had a design that was actually developed by Bill Wilson's office, the architect. and Ankrum implemented the project as the executive architect. And then we moved into phase 2, and as we were, the first pass at phase 2 was basically a building that was very much like phase 1 and using the same unit plans. But as we had gone through phase 1, we recognized how hamstrung we were by the, what I'll call, relative inefficiency of the unit plan in phase 1, especially as we were pursuing passive house. So we talked about looking at that aspect ratio in phase 2. And what you see here is the 1-bedroom unit plans from phase 1 and phase 2. They're roughly the same size, a little bit smaller on phase 2. But what's significant there is phase 1, it was 30 feet wide, and on phase 2, it was reduced to 23 feet. What happens with that change? Well, a couple things. That simple singular change changes some quantities significantly. The amount of skin you have to build per unit is reduced 20% by changing that width of that unit. And then if you look at the yellow area, that's the common area or the corridor that's servicing each unit. And that simple change reduced the amount of corridor we build per apartment in the building by 32%. So corridor isn't particularly expensive, but skin, especially on a passive house building, is quite expensive. It should be expensive. But this is one of the things that happens when you optimize Widget. If we aggregate the savings that I'm talking about there across the projects, this is a diagram of the phase 1 plan with those mostly 1-bedroom unit plans. Same thing happened at the 2-bedroom units. You can see how wide those 2-bedroom units are. We had 57 units in phase 1, and I mentioned before, 58,000 square feet. That's a little over 1,000 square feet per unit, and almost 900 square feet per unit for skin, and it was $160,000 a unit. Now the diagram for phase 2, interestingly enough, actually go back here a little bit. Those buildings that you see there are both 3 stories tall, and they both have the very same number of units. Actually, phase 2 has 1 additional unit. And again, the unit mix is essentially the same. So you see a building form on phase 2 that's much more efficient. And here's where it shows up in the numbers. We have 58 units. The amount of building area on a per unit basis is reduced from over 1,000 to 860. The skin is from nearly 900 square feet per unit down to less than 700. And the cost per unit went down to 147,000. That was the 8% reduction. And then again, it was, if you figured the escalation, it was more than a 15% reduction between the two. And a lot of it just that raw efficiency of the building layout, starting with the unit plan. So I don't have time to go into the details of unit plan optimization, but we've thought a lot about this as well, what we've seen, what we think works, things that are problematic, and we've laid down a set of principles for thinking about unit layout and planning, and put that into a white paper as well. So again, if people are interested, we can share that with you after the talk if you reach out to us. And I just don't have the time to go into all the details, but just a little illustration of what we're talking about. What you see here is what we call a typical 1-bedroom unit plan that we might see. It's 600 square feet area, 24 feet wide by 25 feet deep. We've seen this in minor variations, hundreds of times over, certainly in the 21 years I've been at Walsh, but over 50 years, a lot of 1-bedrooms look like that. It's 600 square feet. And when we're talking about optimizing, we're talking about this notion of, simplifying but not impacting livability, and by just being smarter about things. And I'll get into those in just a minute. But what we've done here is we've reduced the size of the 1-bedroom from 600 square feet to 528 square feet. It's not huge reduction, but it's a selective reduction that we believe still keeps the livability and functionality of the unit intact, and does a whole bunch of other things. Over here on the right, what you see is those two unit plans compared, and you can just do the numbers. And you can look at how many corners there are in each one. And corners are costly because corners lead to additional framing. They lead to additional labor for the drywallers and such. And everybody knows that, you know, some units are simply configured, some units are highly configured, and a highly configured unit costs a lot more to build. Even the numbers of doors have been reduced from 5 to 3. If we further reduce from a 9-foot ceiling to an 8-foot ceiling, and we reduce the surface areas of the lengths of the walls, the actual square footage of the walls within the unit. So you can think of this as a unit, a home that has to be drywalled, and then it has to be painted. You can see it reduces from 1,728 square feet down to 1,360 square feet. So I didn't do the percentage on that, but it's 15 to 20% reduction in drywall and paint. So, but I would argue that this unit on the right has, you know, every bit of the livability of the unit on the left. Notably, there's this big area in the unit on the left that is kind of unfurnishable and uninhabitable, but is all dedicated to circulation. And the unit on the right doesn't have very much of that. So now you can talk about the qualitative difference of a unit that has an enclosed kitchen versus one that has an open kitchen. And you can take an approach with the unit on the right that would incorporate an enclosed kitchen. It would still work. But I would argue that there's a value in the open kitchen in that it keeps the space very open and flexible for layout, accessibility, and such things like that. There's a whole thought process that goes into what we're thinking about with units, and even some suggested unit plans that we've developed that people could look at if they're interested. So we have a client. I've talked to a lot of our different clients in the nonprofit world about these ideas, and I had a client who called one day driving probably fast down the highway. He's based in California in the Bay Area. They do a lot of work in the Northwest, and he's like, we got some land, Mike. We got some land. We want to do some homes, and we want to do that thing you're talking about, that radical simplicity thing. And I was one, I was excited. I was like, let's get on it. Two, I was like, yes, this CEDC thing is kind of a geeky term, and Brad is a more of a marketing guy. So it occurred to me that really that's what we've been talking about, and it took him to help us phrase it. So when it makes sense, we kind of throw that out there, that's what we're really talking about, and hopefully people understand it that way. So I'm going to talk about case studies. I don't know, how are we doing on time? We okay on time?
We're okay on time.
Yeah, this would be a good time to take any more questions about the background, because now I'm going to talk more about the application and the case studies. So if people have questions, I could answer them now.
I don't currently have anyone, but if anyone wants to open their mic maybe and ask a quick question.
I'll keep going.
Then let's see the case studies. Thanks.
Okay. So we're actually working on quite a few projects, applying these ideas now. The two most developed are well into construction and will be done later this year, both on the east side of Portland. One is 124th and Ash, which is 175 units of workforce housing with Reach Community Development, and Gleason Gateway is 159 units, again, workforce housing, really close to the Gateway town center and transit center. They're right off of 405. These projects, and I showed this image a little earlier. I didn't speak to it when I showed it, but when we were developing these ideas, something was going on in the background, which was the Meyer Memorial Trust is a charitable organization based here in Portland, serving Oregon. And they have multiple focuses for their charitable giving, but one of them is affordable housing. And they have been interested for many years in this issue of the cost for affordable housing and why it seems to be, one, escalating so much, and two, why it seems to be so much more than the cost of housing delivered in the market, in the non-affordable market. And they convened a work group starting in, I think, 2015 or 16 to study that issue and advise them on it, because they put a lot of money into this, and I think they want a good return on the money they're putting into it. So they had good questions about why does it take so much to do this. Of course, those who are involved in the industry know that there are a lot of rules and regulations and inefficiencies in the system. And those were all laid out in, let's just call it nauseating detail during the course of the work group that Meyer put together. And they put a report together, and you see it here on the right. If you're interested in that, you can search that online, and it's very interesting. And one of the best pieces done in the nation to study the cost of affordable housing. When the work group concluded its work, Meyer then issued a request for proposals for teams that would submit ideas to demonstrate innovations to bring down the cost of affordable housing. And a number of teams we've been involved with submitted proposals, and actually out of the 3 proposals that were funded, or out of the 5 that were funded, 3 of them were projects that we were involved in, and which includes these 2. The third project is the LISA project, the low-income single adult housing project that we just completed for transition projects in North Portland, which pursued a different approach to innovation. Its approach was modular, and we did a fully modular construction project there of 72 units of basically homeless transitional housing in the Kenton neighborhood. But these 2 projects, Gleason Gateway and 124th and Ash, were intended to be demonstrations of our CEDC ideas, working with 2 different clients and 2 different design teams. 124th and Ash was the first project out of the gate pursuing these ideas in depth. This is in East Portland. Reached the developer. Anchor Moisten is the architect, and frankly, this is the team that we did the Orchards project with. The same team at Walsh working on the project, the same team at Anchor Moisten, and most of the same team from Reach working on it. So a number of years ago, we accomplished the passive houses over 3 phases in Orenco, and it was basically the same team getting together to pursue Reach's new goal, which was cost efficiency, and pursuing that innovation in production of cost-efficient housing. So this project was awarded a Meyer Memorial Trust grant to help fund that, and it funded a couple things. It funded a little bit more work in the pre-construction process relative to our pursuing our target value design process, and we built a mock-up of our optimized widgets or optimized unit plans. We built full-size mock-ups of those, and some of that money went into supporting that. It also went into the procurement of a lean construction coach that Reach brought on board to experiment with lean construction ideas on the project. So they were looking programmatically for a large site that could accommodate anywhere from 150 to almost 200 units. Again, that was part of their conception. If they were going to try to bring costs down significantly, there's a strong belief they need a large site with a good size unit count to pull that off. And we've ended up with 175 units here at 124th and Ash. And we started construction last summer, and will be complete, should be complete in October. We thought 2 months ago we were going to be a month or two ahead of our scheduled delivery because things are going very well. But of course, we've been hit by a little surprise along the way, like everybody else has. So we'll see. We still think we're tracking well for on-time delivery for the project. So, as I mentioned, Reach wanted to pursue lean ideas here on this project. The first and foremost notion there was that they were going to be very clear about what their goals are. And one of them was cost reduction, and they put a number on that. They envisioned, a big, hairy goal for the project of reducing costs 30% in relation to the total development cost limits that Oregon Housing and Community Services sets. So they basically set cost limits for projects, affordable projects that are pursuing tax credit allocations that are based on a per unit limit cost for a 1-bedroom unit and a 2-bedroom. So you add up the numbers of units that are of those various sizes, you take that times the cost limit, and that tells you what your total development cost is for the project. And they set the goal to be 30% below that. It's no secret that some projects exceed that and are, allowed under a variance rule to exceed that cost for hardship reasons, and it's not unusual for that to happen. So certainly, I don't think anybody's achieved a 30% reduction from those targets before. I mentioned before lean process, including more collaboration, and we had a ton more collaboration amongst the team. We were also, I would say, a high performance collaborating team before the project began based on our previous experience at Orchards. But then we brought in the subs in many cases for some of the large trades, in addition to the MEPs, relatively early on to help with calibrating the design, calibrating the specs, and everybody helping Reach meet the target cost goals. I mentioned target value design before, so we implemented that on this project where we estimated the project concept and program. We had the site. There wasn't a lot of complexity to this project and how we might land a building on the site, so it was relatively easy for us to do this. The design team did a great job to track budget as the design was developed. And with a few exceptions, we got off track with landscape. We got off track with the framing a little bit, but we always were able to bring it back with attention to the design. Optimizing the widget, again, I mentioned we actually built, this was the project where we really explored the optimized unit plans, and we built full-size mock-ups of those in tenant space that Reach had in their headquarters building down in South Waterfront, and we're able to, sort of kick the tires of what we were doing with those units. And frankly, Reach even brought their funders in and the stakeholders, the city agency people that fund the projects, the state agency people, so they could see what we were doing as a team. And it was a really great way to show people that, yes, we are trying to refine and optimize, but we're also very attentive to making livable, workable homes while we're doing that. I mentioned getting the subs involved early. So this is the site. This is East Portland, out just east of 405, 122nd Avenue, and Burnside is a Max stop right there, where the Blackburn building is. As some of you may be familiar with that. We just finished that building for Central City Concern as well. And right as we were finishing that, we moved over here to this site and began the ASH project. And this is what I'll call the very definition of an unencumbered site. We did have our utilities in the street there on Ash Street. We had very little slope on this site. It's a roughly 240 feet by 240 feet square, so it's essentially slightly larger than a Portland downtown city block. And there you see a bunch of glorious asphalt paving and some small trees. So this was basically a surplus park and ride for TriMet, right across the street from a really huge park and ride. And they had this, I guess you could call it a fallow park and ride that really wasn't even used. It had a chain link fence around it. And so Reach was successful in securing this through a competitive process with TriMet, and we began work on the project. And following the lean process that we went through, and quite a few iterations of design and sort of testing conceptual approaches to the site, we ended up with what we have for the final design, which you see here in the site diagram is a U-shaped apartment building encircling and a very nice exterior courtyard amenity. It's a double-loaded corridor building, 4 stories of wood frame construction on a concrete slab-on-grade foundation. And then there's just a single double-loaded bar of surface parking on the south edge of the site. There's a large warehouse here for Ron Tonkin car dealership. Most of the, like I said, there was parking here, and then some single-family residential over to the east, and two small single families here on the west. So it made sense to put the surface parking here as a buffer between the courtyard and the building and the warehouse here. And then diagrammatically, you can see how the plan works. This is the first floor level. And what we have is essentially, if we look at a typical floor up above, we have the optimized studio units lining the courtyard, wrapping the outside of the U and facing onto the street facades here. On the north and the east are the 1-bedroom units, and then the few small are the few in number 2-bedroom units are located at the ends of the corridors. And one thing you notice here is this articulation of the street facades. So in general, we tried to pursue a fairly simple massing of the building and form articulation, but here the project wasn't governed by a type 3 review. It was governed by design standards, community design standards out in the neighborhood there. So one of those requirements is that no facade element can exceed 500 square feet in a single plane, or you have to have a 2-foot minimum articulation. So it's literally almost a mechanical implementation of the planning standard to apply to these facades facing the street. So, but again, it's just those same optimized units, and there's just a different, implementation of the outer edge of the unit. Everything else inside stays the same. At the ground floor, there's a little bit of a few stacks of units that are reserved for common areas. but it's a very efficient building layout for the most part. And as you can see, very standardized and straightforward. Here's a view of the courtyard from the parking area, and a finished view of the, you see the step outs. These are the 2-foot bays that articulate that facade per the community design standards. The cladding on the project, in keeping with the, let's call it Spartan budget that Reach put forward here, is fiber cement. And what we did as a team working together with Ankrum, really worked through this idea of something here called superlap, which occurs in about 5 or 6 different areas, little figurative elements around the building that are brought out and emphasized at entry points and touch areas. And that's essentially fiber cement as well, but it was developed by Ankrum with this, what they called superlap. It's basically a panel that's detailed to look like a big lap, or a shingle. It looks like a shingle almost. So it was one way of taking inexpensive materials, try to do something different. You can also see here where they've done something similar with just simple fiber cement materials, great patterning on the facade. So those were attempts to stick with the budget and still do that. What's really cool about the project is when we did all of that work as a team, this is many years after we did the Orchards project, we went out to bid and put that project, or that cost together, and we were at $111,000 a unit to do this project. So a pretty major reduction in construction cost on a per unit basis. And relative to Reach's target of 30%, their total development cost for the project, once the big piece of the construction cost went into their final budgeting, was 39%. So it completely blew away their goal for the project. So a great success of application of the ideas. Now this is where things, I think, actually get really cool, because now when you've reduced costs to that level, you can open up the menu, I like to say, and think about, what can you do, to architecturally or with amenities to improve the project or make it a higher quality project or a more durable project. And this is just, there could be many more things added to this menu, but these are just some examples of things we might do. In this case, we didn't have balconies, individual balconies on the project for the units. We have the big courtyard amenity, but you could look at that. You could certainly look at a more premium cladding. Reach did want to look at putting standing seam metal roof on the project and ultimately decided not to do that, but we are putting a very large PV array on the roof. We've put in upgraded insulation materials and such. That was the architectural menu. This is what I call the menu of the performance upgrades you can look at. And these are the typical items. I mean, it's not a super long list. These are the things you would do when you're looking at pushing your building, your affordable housing to a much higher level of performance than the code minimum or what we even typically see. And as part of our thought process on the ASH project, we wanted to explore this a little bit more. So we said, what if Reach or another nonprofit client did want to pursue Passive House, did want to pursue even the goal of a zero energy ready building? What would it take to get there from our baseline that we've developed and frankly we're building? And if you think in those terms, what we have a building is, as designed, is it has an EUI of roughly 36. And we would think if you want to pursue Passive House or zero energy ready, you'd be looking at the Passive House level 22 to 23 EUI. And if you want to really truly get down to the zero energy ready level, you'd be down in the 15 to 16 range. So that's kind of the target EUI range we wanted to think about how we might do that. And we basically looked at that menu of performance upgrades and how we would implement that. One thing we did is we got a hold of a fellow we know, Skylar Swinford, who's now in Boise, used to be in Portland. He's a great certified passive house consultant and modeler. And we ran through a whole bunch of scenarios of how we would take the 124th and Ash design baseline and get it to the passive house and zero energy ready levels. And so we looked at a bunch of different paths, and he produced a number of reports related on those paths. And we found what we believe is a fairly cost-effective, or the most cost-effective path to pursue passive house, which you see represented here by all of our criteria being met with the green checks. Essentially what we were doing is looking at our menu of upgrades and looking at them from a cost standpoint. The other filter to think about this is that notion of a 5% premium or add back into a project where you've reduced cost. If you think in terms of that 5% for performance I talked about earlier, if we apply that to the Ash project here, we're at about $19.5 million on our GMP cost for the project. That's the construction cost. If you take 5% of that, that is just under $1 million of a rough budget for these upgrades. If we were going to stay within that conception. And we, again, through the modeling with Skylar and cost estimating done by our chief estimator, Ed Sloop, and Jay Neese, our senior project manager on this project, we basically itemized all of those and how the cost would associate with those various measures that were taking us to the passive house level. So what you see here is the cost associated with the different measures. The balanced ventilation system is actually no cost because REACH, as a standard for all of their projects, they have balanced ventilation. We do direct duct the fresh air to the apartments. They don't always do heat recovery, and in the case of the Ash Street project, we didn't have heat recovery, so that is an add. And a big part of that is the units themselves, but another part of that is how you run the duct work. And so you see $150,000 for ancillary costs, which is basically building a bunch of framework and air sealing and insulation dog runs in the attic, the otherwise vented attic, to run the heat recovery return ducts. So it's quite complicated. Anyway, I won't go through all of those items, but when we added all that up, we were just under the $1 million of items to get to the passive house level of performance, the most cost-efficient, cost-effective path that we identified with Skylar. And if you do that, that's just under 5%. And if we think about it from what's that costing on a per unit basis, that's just $6,000 per unit to create passive house homes on this project that already is incredibly cost-effective as at its baseline. So even if you added the $6,000 per unit, it would still, I would argue, be the lowest cost affordable project in the Portland Metro right now. So because of circumstances, REACH did not pursue many of those measures. We did do the increased R value. Like it shows there, we've got the high efficiency lighting program and the balanced ventilation in the project, but it was just sort of too late in the project process once they got the funding and the closing on the project to take in some of these elements, and they declined to pursue them. But it's all good learning that they're very excited about and would like to implement on future projects because the path has been demonstrated. So some people are interested, many people are interested in what does it take to get to zero energy ready, and that requires you taking it, as I mentioned, from the 22 to 23 EUI target that you would have for passive house down quite a bit lower. I mean, another 25-30% lower to the 15 to 16 EUI range. So the measures to do that would actually mean shifting the heating and cooling system from electric resistance without cooling in the apartments to a VRF heating and cooling system, and to shift the water heating to a heat pump water heater system, base system, rather than a condensing gas boiler system, which is in the baseline. So those items have significant price tags, and when we add those in, then our premium bumps up almost to 14%. But still, again, if you look at it on a per cost or a per unit basis, it would be only $15,000 on a per unit basis to bring the project to the zero energy ready level. So again, we're not there where we can say we can do zero energy ready for that 5% premium, but we can get a long way down the path towards that. This is a neat shot from a drone a couple of months ago while we were getting close to topping out the building there on the east side, and an aerial view that shows it. We used all advanced framing in the project, and that was one of the ways to help bring costs down, and working with a creative engineer, Scott Neiseth, with Stonewood, key member of the design team, to kind of help us really optimize the structural system as part of the whole CEDC process. The Gleason Gateway project, this is very quick. I think this project, I just want to show it to illustrate that this is a replicable result. It isn't a one-off at Ash Street. So the Gleason Gateway is maybe 20 blocks away, again, out on the east side. You see it's fairly close to where Ash Street is there, the circle on the right. And again, a great transit-oriented development location, which was key for Northwest to pursue. Here's a view of the image of the project through the design review process. So quite a bit different approach and result in terms of architectural character and quality. This project has mostly a flat roof. It has a couple of steep slope roof elements, but mostly a flat roof or low slope roof. This project had to go through full design review. It had to go in front of the commission. So we've got mostly brick cladding on this project as compared to the fiber cement that's on the Ash project. So the material qualities are a little higher here. The approach to the roof, we see that low slope roofs as a essential design element are more costly than pitched roofs with asphalt shingle finish. So it was lacking some of the cost saving features of the Ash Street project. But as you'll see in a minute, we still achieved a really great cost result here while we were integrating all of those overlays of design quality that were essential to this project. So I mentioned before, this is with Northwest Housing Alternatives. MWA was the architecture firm that was leading design. And this project also received the Meyer Memorial Trust grant. We thank them for their support. And again, NHA was looking for a large site where they could do a good number of units to get that economy of scale. They were shooting for 120 to 160, and we were able to find a unit mix and a massing that worked for the site for to achieve 159 total. This site actually had a much higher height limit, and because it's in the gateway town center area, and we could have gone much higher, but it would have proven to be much more costly to do that in concrete frame construction. So we stuck with the result we came up with here with the 159 units in a 4-story building, and started construction last spring, a year ago almost, last May, and will be finished in August, in just a couple of months. So basically the same kit of parts that we were talking about with Ash that came through our optimization process with the unit plans, and a focus on standardizing elements such as the elevator shafts and stair enclosures and the stair sizing. The floor-to-floor heights on these projects are all the same. They're an optimized dimension that works really well, so that you're just installing 8-foot sheets of drywall or 9-foot sheets of drywall, and you're not having to cut boards and such like that. So it's sort of a strange, narrow, deep site. So on the right here, it faces onto Gleason, the main street, and so some of the community quasi-public common area space is fronting onto that, and then you got units on the ground floor, and then the units above are all residential. So I mentioned the overlay of design review and certain aspects of the design that were more costly than we were able to do on Ash, but it still didn't blow up the model. Really, we got a great result. We ended up at $123,000 a unit for this project. And again, it was up from 111 at Ash, but still a great result in terms of cost efficiency. And one of the ways we've been measuring that is we've been tracking, and this is a spreadsheet I'm sure none of you can read unless you're looking really closely. I'll give you a few seconds. You can take a screenshot if you want. This is basically, we believe you can't really, you can't know what you don't measure. So we've been looking, as we've focused on cost efficiency and cost effectiveness, we've been looking at how does what we're doing and where we're applying these ideas, how does it compare to what else is going on? So what you see here is all the affordable housing projects in the Portland area over the last 4 to 5 years that have received public subsidy, and all of the readily collectible new metrics from those projects that we were able to gather mostly or almost entirely from the public record, either from OHCS or Portland Housing Bureau. And we assembled this and then put it in and sorted it by total development cost per unit. So you see that's the column here in the middle, and sort of zeroing in a little bit closer. So you see the projects measured on a hard construction cost per unit basis. You see the numbers for them. And again, back to the total development cost per unit. The range for total development cost per unit is $161,000 per unit up to nearly 400. This actually cuts off. There is a project that's just over 400,000 per unit. So that's the range. And then the cost per unit ranges from 111, which is the Ash Street project, up to north of 300,000 a unit. So you see a wide range, and these aren't sorted by, numbers of bedrooms and such. So those obviously relate to the cost per unit. But we our 2 projects we're talking about here basically delivered projects that were at the very low end of the cost range, and I think really demonstrate that the discipline of what we're talking about can really achieve not only results on one project, but we believe it's replicable. We actually are working on the lowest project here is the TPI, the Lisa project that I mentioned earlier. It was also, frankly, all 3 of these projects received the Meyer Memorial Trust grant. And it's a bit of an outlier, the Lisa project, because it's many of these units are they're essentially sleeping rooms. They don't have bedrooms and bathrooms. They have half of the units have common bathrooms and a common kitchen. So it's a bit of an outlier for that, but certainly 124th and Ash and the Gateway project are, you know, fully built out apartment homes and such, as are most of these other projects here. So the last thing I want to leave everybody with is this this idea, which is efficiency has another way of paying off, which is everything we've talked about to this point has been about first cost. And when we design efficiently and build efficiently, we basically create an asset for the owner and those who live in the buildings that will be more cost effective to maintain and to operate and maintain over time, because there's literally a reduction in the quantity on a per unit and per person basis that these structures have. So it does a great job to reduce costs over time through that efficiency. And then when you get to the point downstream where you have to re-roof or repaint or re-caulk a building, that reduced quantity is also paying off in a lower cost to do those. So I think with that, I will end, because I think we're at the end of our time limit, and maybe I can take questions if I haven't run everybody off yet.
Well, first, I really want to thank you, Mike. That was an amazing presentation. I'm so curious. I live in the Gateway neighborhood, and it's nice to see great projects going up.
Awesome.
With that, I want to just remind those that may have a comment a little bit late, if you're interested in getting an AIA credit, please ping me your email, or not email, and AIA number in the chat window. And with that, there are a few questions from the chat window, and I think I might actually just try and call on those people if you want to speak up. So, hey, Allie, would you like to ask Mike your question first?
Yeah, just a sec. I gotta scroll up to it because that's why I wrote it.
Sorry.
So, Mike, you mentioned cost per unit and cost per square foot, and there are multiple ways to measure unit cost or cost on a project, and then you showed your spreadsheet. I was curious if you have an opinion on the most informative or useful way to measure cost across housing projects, and then part B is if that approach would be applicable to other project types in your mind.
Well, I think the best metric is cost per person, because what we are doing is we are serving people, and with these buildings and facilities and homes, and the best way to measure them would be cost per person. So the second best way would be cost per bedroom, because bedroom is sort of it's a stand-in for a person. And then you get to cost per unit, which is a better metric than cost per square foot, which is the least valuable metric. It's the easiest one to compare between buildings because you I guess because square feet are square feet, so you can say that, but it's at the same time it's the worst one, because frankly we don't build square feet. What we build is homes, and we build classrooms, and we build offices, and we build them for people, and it really is more a function of how well it's designed to achieve its function, which includes how you can live in it, but it also includes how does it operate in the environment, and how can you heat it and cool it and ventilate it. So I just think, the best easy to compare across projects metric is cost per unit, but we tend to default to cost per bedroom when we're talking about it with clients now, because it's the easiest one. There's different ways that people consider how many people live in a one-bedroom apartment versus a two-bedroom apartment. If you get into some of the ethnic communities, they'll crowd a lot of people into a 3-bedroom apartment that you wouldn't have in other communities. So it's really hard to measure how many people are being housed. So that's also difficult. But ultimately, when we're talking about affordable housing and providing the asset to the community, it really, I think, should be measured in terms of how much are we spending to deliver a home for a person.
I think that's fantastic. William, you had a question also. Would you like to share?
Yeah, I'll unmute real quick. So I was recently listening to a real estate economist, and he was speaking about our industry and that we've historically built at or below capacity in the multifamily development. And given your expertise in this area, do you view this as an accurate statement? And if so, what could we do? What public-private partnerships maybe could we explore to increase the inventory supply, which would also help drive down the price to the renter?
Well, those when you read the numbers, they're daunting. I mean, we're delivering, it seems like, a quarter of the units that are needed in pretty much every, at least, growing community across the country. And it's worse on the coast and in some select urban areas in the middle. I don't know. It's so difficult to get things done now with all of the constraints on the projects, from entitlements to finding subcontractors to getting the work done with the design infrastructure we have in each different community. And then there's a lot of NIMBYism and a lot of resistance to it. I think the good thing is we've gotten to the point where, at least in the Portland area, and perhaps some of you who are from other places can speak to it, but in Portland, a couple years ago, it was like the dam burst, and suddenly everybody was for affordable housing suddenly, and it's become almost the most important political issue. Maybe it's been eclipsed now by current circumstances, but it's not far behind. But at the same time, nobody's giving on the zoning requirements. We were just looking at a site out at the coast, and it would be a great site. It's a former golf course that's lying fallow now, and it's not like a natural site, and it's not farmland, even though it's zoned farmland, and it would be great for affordable housing. But the county folks out there told us that's a 10-year battle, and you'll probably lose at Luba. And so the community knows they need homes, but there's no will to really set up a land use planning system that will allow it more. So all of that said, I will say, especially for those of you who aren't in Portland, a great thing happened here in Portland in the last year, where the city and the state have both worked towards getting rid of single-family zoning, and in our city. So basically, the city's been essentially rezoned, and you're allowed still to be determined how many units, but there's definitely going to be at least duplexes and triplexes going on single-family lots anywhere in the state, in large communities around the state. And in Portland, our planning department and city council are considering at least 4 units per lot, and possibly 6 to 8 units per lot, as basically recognizing that there are zoning restrictions that are 100 years old now that prevent naturally occurring affordable housing from happening everywhere. And obviously, those kind of developments that might come along might be problematic, but the fact that our zoning doesn't allow most of this housing that we need is the biggest obstacle.
All right. So Charisse, you had a question about collaboration. You want to share?
I was just curious, at the early design end of things, what your biggest challenges are during that time that all of the architects or specifiers on this call could benefit by understanding more and maybe changing the way they work at the early collaboration phase, or just know to ask some of the right questions. I've worked on some projects like this, and it feels like you're changing things every 5 minutes, which really kills the budget hours wise, usually in a design contract. So what could we do better?
Yeah, I think there is an element to this that requires, let's say, thinking outside the box and working outside the box a little bit, and that actually takes time. I mean, a good example is the specs, and on both of these projects, we asked the design teams and the spec writers at the firms to like work with us, and let's pare out all of the boilerplate, you know, that is not applicable, and you know that's a task. And they did it, and I'm not sure how they were compensated for it. I think they maybe did it as part of a client service for the mission of these projects, and worked with us. And in each case, I mean, we literally trimmed. I mean, we had a goal to reduce the thickness of the spec book, because you know the joke is the thickness of the spec book has an impact on the final cost of the project, and we all know why spec books get bigger and bigger and bigger. But there is unnecessary information in there. There's just a practical reason it's in there, and that you don't distill it out on every project because there's a cost associated with distilling it out. And so that's just one example of what we did on actually both. You know, each of those teams did it in their different ways on these projects. That's a lean method, but it's some of these lean methods actually take more time and they cost more soft cost, but you can potentially achieve hard cost savings on the back end of them.
And I imagine also CA
Go ahead.
process savings.
Well, the CA is a great story on our Ash Street project. It's I haven't been out there for 3 weeks, but 3 weeks ago, when we were 8-9 months into construction, we were 2/3 of the way through 60% of the way through construction. Richard Stevenson's our superintendent. How many RFIs do we have, Richard? We've got 31 RFIs. It's a $20 million project with 31 RFIs.
That's crazy. I love it.
Yeah, we're all sitting there going, no way, I gotta see it. That's amazing. That is really amazing.
Scott had a question about the design standards on Ash Street. Scott, are you still with us?
Yeah, I sure am. It was just a question of just how much the 2-foot articulation rule for the one project, do you have like what the overall cost for that is? I know that people invent them for various personal reasons and otherwise. Seems like neighborhood has their own design overlay committees. Do you could you just, I know you certainly didn't take it apart, but could you just throw like a percentage number or something like that? I mean, if people are thinking of putting them together or reevaluating these things, it would be great to have an idea of, you know, what their cost is when they think maybe this is just a simple thing that's not going to have any real effect on the neighborhood.
We actually did cost study that in the schematic design phase. The community design standards allow you to have a non-articulated facade if you're using essentially what they call a premium cladding material, essentially if you're using brick or metal. And, or let's say Euro cladding, and the architects in the room will know what I'm talking about. If you're using siding, you must articulate. That's the way the community design standard is. So we actually looked at the facades being flat on the street facades and being done in brick cladding, and the cost to go that direction, because it was a 4-story building and we would have had to have ledger supported brick, which requires a lot of steel, and it requires you to build heavy framing members in the floor system at the building perimeter. It was a $178,000 ad to go to brick cladding. It was a total ad. So we had savings in the framing because we had a simplified framing approach to the exterior, but we had an increase in cladding cost and the framing material cost for the ledgers, basically the heavy timber ledgers that had to go in to support the support steel for the brick. So Reach said, we'd love a brick clad building here, but that's counter to our cost efficiency goal for the projects. They decided to go down the path with articulation and fiber cement siding.
Okay, thanks, Mike.
Yeah, thank you for the question. Gail, are you still with us? Looks like you are.
I am unmuted now. Yes, I am. Thank you very much. This has been really informational and really well done. I appreciate that. I was wondering what your findings are for those darn party walls that have to be rated and soundproofed, and what's your most efficient construction for that?
Well, that's interesting. We do a lot of work in Seattle, and we're working with clients and design teams that are trying to implement these ideas in Seattle. And in Seattle, they are absolutely insistent, and I think it's driven by the acoustic consultants who serve the market there, that they must be separate stud walls with a 1/2-inch gap between the studs, separate plates, everything isolated. And then you're putting your RC on one side, your shear ply on the other, and then 1 layer of rock on the RC and 2 layers. I mean, it's a bulletproof wall. It's highly separated, and it meets the code requirements. In Portland, for the last at least 10 years, we've been building a single stud 2x6 wall. It's not a staggered stud wall. It's just a 2x6 wall, standard frame wall. We put RC channel on one side, 2 layers of rock, shear ply when needed, usually needed on the other side, and 1 layer of rock. And that it gets a 51 to 54 STC rating by design of the assembly. And we field tested it on a couple of projects and found that it comes in right there or above on the numbers. So we have not seen that there's a big issue with sound transfer through a simpler, more cost-effective party wall. Would we put it into condos where there's lawyers trolling around the outside of the building waiting for a complaint about acoustics? Probably not, but is it the appropriate solution for affordable housing when we're trying to provide more homes for the same cost? Yes, I think so. So that's what we're doing.
Awesome.
And I shouldn't say that we're doing that that's the design that we're getting from the architects that we're working with in affordable.
Looks like we have a few more questions. Mike, did you have a question? Maybe not.
I don't have a question.
Not you, Mike. Sorry, Mike. Cap?
Yeah.
Or,
Sid.
there's Mike.
So Mike, are
It's
there,
isn't it past your bedtime?
It's way past my bedtime. I just slept through half of your presentation. Sorry. Just wondering if
Mike's in North Carolina, for those of you don't know.
Awesome.
are there additional points in Oregon given to on the QAP, or is there a qualified allocation plan used in in Oregon or specifically Portland to award these affordable housing projects? It's like Pennsylvania gets extra points for certified, passive house certified projects to award them.
There's nothing for passive house. Yeah, and this round, there's a current NOFA round, and it had a point or two for a higher level of energy efficiency, but they actually issued a notice about 4 weeks ago saying they're going to give, because of the COVID situation and everybody scrambling, they're just going to give everybody that credit this time around. So it's not going to make a distinction on this application round.
Thanks for all your great work, and thanks for sharing all this incredible information with us across the country. Good, you're a good asset, Mike.
Thanks, Mike.
It looks like we've got one last question from Joe. Joe, are you still with us? We may have lost Joe for the evening, so unless anyone else has kind of a follow-up question. Well, with that, I would like to say thanks again to Mike. I was really fascinated.
I have a question. Can I ask you a question?
Please.
You asked me earlier. I want to ask the lawyer in the house if he sees any problems with CEDC.
The lawyer wants to know why the government won't reduce their standards to make housing more affordable. I was going to ask you offline, but the question really is there anything being done at the codes level to make housing truly more affordable? It seems to me that those criteria are what are keeping costs up at a higher than anybody would like level.
Yeah, I think the end result is no. I mean, I think there are attempts. Advanced framing is a great, it's a great topic related to that. I mean, there are paths that the code allows to do things more efficiently and cost effectively in design through performance methods. But at the same time that the code is flexible enough to allow that, it's just by its nature, they don't take requirements away. They never do. They always increase requirements. I mean, the energy code is a great example. It only goes in one direction, and you know what? That's as it should be. Is my view of it. But everybody needs to recognize the buildings we build now are not the buildings we built 20 years ago and the ones we built 40 years ago. So it would be really interesting to really study how much of the cost of these buildings are related to all of those changes in code over 20 to 40 years, because there's a big chunk of the cost that's right there in that. And do we want to backtrack on those things? I don't know. I mean, the city of Portland tells us now we have to allow for 2.5 inches of horizontal displacement at the floor line of every big tall building we build in the city of Portland now. And I have a question for the people at the city of Portland who are requiring that, because it's not required in any other jurisdiction in the country where the same physics apply. And I just want to know what's going to happen to the air and water barrier at the floor line of all of those buildings when that 2.5 inches of displacement that's designed into the building happens. And we solve for the 8.5 seismic event, but we're creating a problem for the 5.0 that's going to happen in the next 10 years, or and the building's still going to be standing. And so it's a good example of how I think folks involved in code development and code application sometimes overthink. They're just doing what they do, right? But when you add it all up, sometimes it's overwhelming, and in some cases it's counterproductive, right? So that being the last thing I brought up seems to me counterproductive, and it adds cost, and I'm not sure what value it's really providing. So
yeah, great presentation. Thank you.
You bet, Jack. Nice to see you.
So Joe actually messaged me. He's with the sleeping baby, so I'm gonna ask him for him. He was asking, speaking of things costing more, what's your experience with subcontractors actually reducing their bids when the dimensions are standardized and their work is presumably made easier?
It's a great question because you got to grab the subs and you got to rub their nose in it. Because if you just send them the plans, they're going to square foot it and they're going to like think all that crazy stuff they had to deal with on the last Walsh job they worked on with this architect is what they're going to have to deal with this time. This is what I get back what I said about the sub base that serves the multifamily market. It's not a particularly sophisticated group of contractors for the most part. I mean, on really large urban, commercial, heavy projects, you're dealing with a different caliber of sub and more sophistication. But most of these subs are basically large outfits that are basically those pickup operations that people joke about, right? And that's good. I mean, they're enterprising people. They're good people. They might be a little rough on the edges sometimes, but they're good people, and they've got good people working under them to get all this stuff done that we need to have done. But yeah, you can, you have to educate them about what you're up to. So that's one of the things we've done. We've had the MEP subs in, we've had the framers in, we've had the drywallers in some cases the cladding subs, the roofers, and talk about what we're doing to make their life easier. We love to ask them, if you were king for a day, what would you change about the specs? What would you change about the design and the details? And this is really the important piece, is we listen to them. And we carry it through to the design team, or the design team's at the table when they're bringing it up, and they embrace it. And that's when the subs start moving. But this is the key. This is the thing we can end on, which is, I think we're never going to get the savings until the second time. Because when we'll really see the savings is when we implement these ideas in the design. They give us a little bit of credit for it on job A, and then they see what the results are. And really what they'll see is that they just had more money hanging out of their pockets when the job was done than they've seen in a while. And that's when they'll say, hey, well, that stuff they were talking about, that works. And then one, I want that next job. And two, I'll give them some money back on that next job. So I think we got to get through working this discipline and applying it, telling them about it, and letting them see the results of it. That's when we'll see the savings.
Well, I think that's a great sentiment to end on. So again, thanks, Mike. Thanks for everyone for showing up tonight. We're so happy to have you here. And hopefully we'll see you all again real soon.
Thank you.
Good night, guys.
Adios, everybody. Cheers.
Cheers.
Thanks, Mike.